Hi guys, in this video we're going to look at trigonometric limits, and there's a couple of special trig limits that we need to know. The first one here is that if x is measured in radians, then sine x over x, as x tends towards 0, this limit will become equal to 1. And if we just switch the denominator and numerator around, you'll see exactly the same thing happen. So it doesn't matter whether it's sine x over x or x over sine x. If we take the limit as x heads towards 0, then that will go towards 1, it tends towards 1. Okay, the other thing we also know is we know that cos of 0 is equal to 1. We've done that in the trigonometric section, and that means that obviously if the limit as x tends towards 0, cos of anything in front of the x will also equal to 1. So a is a constant here. Okay, so if you see cos 5x and you take the limit of x heading towards 0, it's 1. So let me just write that down for you. So for example here, if I had cos 5x and I'm taking the limit as x tends towards 0, that's equal to 1. Okay, if it's a tan, all we do is we write it, because remember tan is equal to sine over cos. So all we do is write in terms of sines and cosines, and we just use our limit ideas from the two things I said here and here. Okay, so we're going to do a couple of examples here to show you how this works. So the first one we've got to do is evaluate the limit of x heading towards infinity of sine 5x over 4x. Now notice that these x's have to be the same here, and these aren't. This is 5x and 4x. Notice that this is x and x. So what we need to do is we need to get 5x somehow on the bottom so that we can get sine 5x over 5x. So just going to write this down. So we've got lim as x heads off to 0 of sine 5x over 4x. Now, what I'm going to do is I'm just going to break it up. So limit as x heads off to 0, and I'm going to make this sine 5x is going to stay exactly where it is on the top. And what I'm going to do is I'm going to put an x there, and I'm going to multiply that by 1 over 4. So notice all I've done here is I've broken up the denominator and put the x on the bottom here, and I've moved the 4 outside. So it's exactly the same thing, apart from I've just broken it up slightly. Okay, so if I multiply this with this, I'm going to get back to this. Now the reason I've done this is so that I can get the x's underneath this sine 5x here. I still have the issue, in order to use this limit rule, I need to have the same number of x's on the top as there is on the bottom. Notice I have 5x on the top, I only have x on the bottom. The way I can deal with that is I can multiply the bottom by 5. Now if I multiply the bottom by 5, so we go here, if I put a 5 here, that means I must multiply the numerator by 5 as well. So that means I have to put a 5 here. Okay, so what I'm doing is I'm multiplying both top and bottom by 5. I'm not changing the expression, because 5 divided by 5 is 1. So I'm essentially multiplying by 1, which won't change. I've just put it to a different form. That's all. I'm not actually changing the value of this expression here. Once I have that, I can combine the 5. So let's just rewrite this again. I've got the limit as x heads off to 0. I can now say that this is the same as 5 multiplied by sine 5x over 5x multiplied by, on the other side, a quarter. I'm now going to take the limit, and we know that as x heads towards 0, if I've got sine ax over ax, so sine 5x over 5x here, what's going to happen is, according to our rule, that's going to change to 1. So I end up with 5 by 1 multiplied by a quarter, which is 5 over 4, and that's the limit. So again, just to show you what's happened, we ended up with our original one here, sine 5x over 4x. I've broken it up, sine 5x over x multiplied by a quarter. The issue is the fact that I need a 5x on the bottom, so I'm going to multiply the bottom by 5, which means I have to multiply the top by 5. I now have sine 5x over 5x, that's there. I have the 5, which is this one here. I have the quarter, which is on the right hand side here. I'm now going to take the limit, which means that this sine 5x over 5x is going to change to 1 due to this rule here. And I have 5 times 1 times a quarter, which is equal to 5 over 4. Okay, let's have a look at the next one. So over here we have the lim as x heads off to 0 of 3 sine 2x over 5x cos of 3x. Okay, So let's have a look here. So what I'm trying to do is I'm trying to break it up. I've not taken the limit yet, so I have to still write the limit. X is heading off to 0. And I'm going to break up the top. So say it's the same as 3 by sine 2x. Now on the bottom, I'm going to break up the 5. So 3, so make that the 5 there, and sine 2x. And I'm going to put x underneath that, and then I'm going to multiply that by 1 over cos 3x. So just to recap what I've done here, look, that 3 is that 3 there. I have a sine 2x, so that's the 3 by sine 2x. I then have the 5. I've got the x. I need to get some x's under the sine 2x so that I can use this rule here. And then I've got 1 over cos 3x over on this side here. Now the next thing I have to think about is the fact if I want to take the limit, then this 2x here must be the same as the 2x on the bottom here. It isn't at the moment, so I need to multiply this by 2 on the bottom, which means I need to multiply it by 2 on the top. So I'm just going to put that in blue like I did before. So this I'm going to do is 2 and 2 there. Okay, so now I have sine 2x over 2x, which means when I take the limit, that's going to collapse into 1. Notice that we've already said if we have cos of ax, and this is cos of 3x, as we take the limit towards 0, this will collapse to 1. So this will collapse to 1 when I have this x heading off to 0. Okay, so I'm just going to quickly rewrite that. So we're going to end up with the lim as x heads off to 0. We've got 3 over 5, and then we've got multiplied by 2, and then we've got sine 2x over 2x multiplied by 1 over cos 3x. Now when we take the limit, which is what we're going to do next, this is going to collapse down into 1, or change to 1, so we're going to head towards 1. This one's also going to head towards 1, because of this rule we'll have 1 divided by 1, and we're left with 3/5 times 2, and that'll be it, we'll be done. So we've now got 3/5 times 2 times 1 times 1, and that is 6/5 is now my limit.